Alright, we're still on section 4.4. This is the mean value theorem, and we are on problem number 184. And the question is asking, find the conditions for y equals e to the x minus b to have one root. So f of x equals e to the x minus some b value. And before I look at that explicitly, let's go ahead and look at just e to the x. So over here on my graphing calculator, I've got e to the x, and if we graph that function, it looks like this. Now it does look like it is obtaining the value 0, but if I zoomed in on this graph gets closer and closer to a y value of 0, but never quite gets there. So it doesn't have a y-intercept. So as long as we subtract any positive number here, so this is as long as b is just bigger than 0, then this function will actually dip below the x-axis and have at least one root. So if I look at this now, it will look like this. Oops. Something like this. And now I'm going to have something like this is b here. And if I look at the graphing calculator, in fact, if I did something like for my y equals, let's just say I subtracted 3. It's going to bring that entire graph down 3 units. And so here, if we look here, it looks like there's only one 0 or one root. And you could play around with this. I could subtract just 100th. And now I'll zoom in on this. Maybe I'll just change the window here. We'll go minus 10 to 10, but we'll go from negative 1 to 1 for a y value. And you see right here, it crosses and has one, exactly one real 0. So, of course, this is just from intuition. This isn't proof by any means. So we want to show, using the ideas from calculus, to show that there's exactly 1 0. So here, so right here, there's going to be 0. This is for any b that's positive. Okay, so here it's going to be so this is minus b, and here b is something that's positive here. And so it'll dip below there. And so if I try to figure out when this is 0, I'll add b to both sides. And then here, apply the natural log of both sides. So as long as b is positive here, there will be exactly one particular root. Now this isn't using any calculus other than just trying to figure out when the function value goes to 0, and natural log b equals x is your value where the function goes to 0. Now if I looked at the derivative of f of x, of course the derivative of a constant is 0, so we just get e to the x. Okay. Now e to the x is always positive for any real number. So that means the derivative is increasing. The slope is getting more and more steep, or more and more positive. So no matter what value you have, as far as an x value, eventually the function will increase to the point where it will get large enough to at least get to a value of 0, and of course get even larger than 0. So here we don't need anything sophisticated other than knowing that the function is always increasing because the derivative is positive, and since we subtract any positive number, it will bring the function down below the x-axis, and because the slope is always positive, it will eventually increase past f value of, or a y value of 0, and that value is unique because natural log b is the real number where the function will go to 0. And that concludes problem 184.